Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so on the previous day we have discussed about speed. Today we will be going to discuss velocity, and if time permits, we will be discussing about acceleration also. Okay, so without wasting much time, let's start our topic. And please do share our video if you like the video. Please press the like button and also subscribe button so that you will get the regular updates, and please like the video so that these kind of videos are shared to more people so that science becomes easier for everyone. Okay, so with that, let us start the topic. We have already discussed a preliminary concept of velocity, isn't it? So today we will be discussing in details about velocity. So first of all, when you are talking of velocity, what does velocity mean? Okay, what does velocity mean? So velocity actually means the rate of change of displacement. Rate of change of displacement. Okay, while discussing speed, we have said that speed was the rate of change of distance. So here it's rate of change of displacement. Okay, so displacement and distance are two different things, and I hope by now you have got the concept clear. And if you have not, please do watch the previous videos. The concept of displacement and distance has been clearly discussed. Okay, so when you are saying rate of change of displacement, as I have already discussed in while saying about speed, that rate of change means how the displacement is changing with respect to time. That is called displacement. Now, as you know, displacement is a vector quantity. Distance was a scalar quantity, displacement is a vector quantity, because you know, while we try to define displacement, we need to define the direction. That is the first and foremost thing. So we know that physical quantities which are actually require the magnitude unit as well as the direction to be specified, those units are called those physical quantities are called vector quantity. So definitely displacement is a vector quantity, there is no doubt in it. So obviously when we are saying that rate of change of displacement, we are saying that so we can say that the displacement, change in displacement, so velocity can be denoted as the change in displacement, okay, by the time taken for this change. Okay, time taken for this change. Fine. Now, so as you know, the displacement is a vector quantity, whereas time, is it a vector or scalar? Please try to recapitulate. Time, as you have said, do not need any direction, so it's a scalar quantity. So when you divide a vector quantity by a scalar quantity, the quantity that you obtain is also a vector quantity. Fine. Now, so displacement, that is this velocity, for velocity you have to be specific about the direction. So when you are saying that a car is moving from, say, there are two places let me just clarify it. There are two places, A and B. Okay, so there are, say, two places A and B. Now a car is moving from place A to B. Okay, car is moving from place A to B. Okay, so it is now moving from place A to B, and it has a, say, constant speed of 40 km per hour. So speed is 40 km per hour, no problem, no issue in that. But when you are saying that what is the velocity, now velocity is a vector quantity, and as you have seen in displacement, distance, okay, a displacement, okay, vector quantity, scalar quantities is always positive, there is no positive or negative, but vector quantities are considered to be positive or negative, because when you actually change the direction 180 degree opposite, say if you consider this direction to be positive, and if you just change this direction 180 degree opposite, this is negative. Okay, so vector quantities can be positive or negative. Distance is a scalar quantity, it is always positive. However, displacement can be positive as well as negative. Please note it down in your difference between distance and displacement. If I am not said, or if you have just missed it out, please note it that distance is always positive, whereas displacement may be positive or negative. So when you are going from, when a car is, say, going from A to B, if I consider this direction to be positive, okay, the right moving, when moving towards the right is taken as to be positive, then displacement of the car from A to B is, say suppose the distance between A and B is okay, A to B, this distance is say 100 km, or say rather, okay, so 120 km, okay, A to B, okay, this distance. Now when I say that the car is moving from A to B, okay, we will be saying that the car has a positive displacement of 120 km. Say it's a straight road, so displacement and distance are same. So the car is said to have a positive displacement of 120 km. And whereas if the car returns from B to A, if I take this direction to be positive, it is just arbitrary. You can take this direction to be negative also, okay. But generally we take the right direction as the positive. So when the car returns from B to A, that direction B to A, when it comes from B to A, that direction is taken to as negative. So when it comes from B to A, then that direction is regarded as negative, okay. So when we say that the car is moving from B to A, it is said to have a displacement of minus 120 km, okay. Likewise, when the car is moving from A to B and you are saying that the car is having a constant speed of, or we are saying that the car is having a constant speed of 40 km per hour, we will say that the velocity of the car from A to B, velocity denoted by V, A to B is plus 40 km per hour, okay. Whereas when I say that the car is returning from say B to A, okay, it is returning from B to A and now it is coming back from B to A at a speed of say 50 km per hour, okay. It may be same also, that is not an issue. Then we will be saying that the velocity of the car from B to A is nothing but minus 40 km per hour, okay. So this is the notation, or this is how you must write the velocity of the car while it is moving from B to A and A to B again. So I think the concept of velocity is clear, okay. So for velocity you need to, as you can see from this video clearly, we need to actually specify both the magnitude, the unit as well as the direction, okay. It's very important. Fine. So this is how we can denote velocity. Now as we have discussed the speed, there was uniform speed, non-uniform speed, instantaneous speed. Likewise in velocity also we have uniform velocity, non-uniform velocity as well as instantaneous velocity. Let us discuss in details, okay. So I think you have noted down whatever is written here. If not, please pause the video and note it down, okay. So I'm just rubbing it off now. So velocity can be also like speed of three types, okay. So what are those three types? Let us discuss, okay. Now first is uniform velocity. Uniform velocity, okay. Now what is uniform velocity? Say now when you have talked about speed, we have said that when a body travels equal distance in equal time intervals, isn't it? For velocity we need to actually say that the first of all the body should be traveling equal distance in equal time interval. That is the first point. And the second point that needs to be also assured is that the direction of the body must remain same. The direction should not change, because when a body is say moving with a constant speed of 40 km per hour, suppose consider a body is moving with a constant speed of 40 km per hour and it is constantly traveling in from south to north direction, then it is said to have a uniform velocity. So for velocity to be uniform in case of a body, both the magnitude of the velocity, or rather say speed, and the direction of the motion should remain same throughout the time interval. So that is uniform velocity. So in other words, you can also regard this as that the displacement of the body, if we say that the displacement of the body should be same in equal time intervals, then you can say that is also uniform velocity. Because whenever you are saying that the displacement is uniform, try to understand this, when you are saying displacement is uniform, we are already actually meaning that, okay, the direction remains same, because displacement same means not only the magnitude or the amount, rather the direction also remains same. So if we say that the distance displacement remains same in equal time intervals, then can also be regarded as uniform velocity. So I think the concept of uniform velocity is clear. Now second comes the non-uniform velocity. Non-uniform velocity. Okay, non-uniform velocity. So what is non-uniform velocity? What is non-uniform velocity? So actually what happens when a body, say non-uniform velocity, actually we can have two conditions. That when a body is, say, moving with a constant speed, say 40 km per hour or 50 km per hour, you look at the speedometer of your car for a certain time interval, and for that total time interval the speedometer of the car shows to be 50 km per hour constantly. It is said to have a constant speed or uniform speed, but say if the car for a certain time, within that 1 hour span of time, for 10 minutes the car moves north, then for 30 minutes the car moves east, then for the rest of the time the car moves south. So the speed remains constant, speed is uniform, but you cannot say that the velocity is also uniform. As the direction has changed, please note it down. If you are just noting it down, please note it down, it will be easier for you to understand. If the speed remains same, fine, but the direction is constantly changing, then the car or the body will be said to have non-uniform velocity, isn't it? Non-uniform velocity. Or in other words, we can also specify it like this, that when the car is moving say in a constant direction northward, but you see that the speedometer is, when you watch the speedometer for a time interval of 1 hour, the speedometer shows first 50 km per hour for 10 minutes, then 60 km per hour for the next 10 minutes, then 30 km per hour for the next 20 minutes, then for the remaining it's 80 km per hour. So what happens? The speed is varying. Then definitely, although the direction remains constant but the speed is changing, it is said to have a non-uniform velocity. So I think the concept of non-uniform velocity is clear. Non-uniform velocity means either the speed remains same but the direction is changing, or say direction remains same, the speed is changing. Both can be the cases, or it can be either one of them or both. In all these cases, the object is said to have actually non-uniform velocity. Okay, so I think concept of non-uniform velocity is clear. Fine. So now this is non-uniform velocity. Now when you are talking of non-uniform velocity, so definitely the velocity is changing, isn't it? Changing. So if the velocity keeps on changing over a certain period of time, then we will have another quantity called instantaneous velocity. What happens? Over a period of time, you are seeing that the velocity is varying. So for that period of time, at any instant, if you watch the, or if you judge the velocity, that what is the value, what is the actual value or direction of the velocity, and you see that the car is moving at that instant at 50 km per hour speed and in the north direction. So for that instant, that is the instantaneous velocity. It may change just after the next instant, after 1 second, after 2 seconds, or after 10 minutes. It may just changed. So generally, when you are talking of instantaneous velocity, the instants that you take should be comparatively small to the total time of the journey. Then those instantaneous values, those particular values at those time frames, okay, those particular times are regarded as instantaneous velocity. Okay, so I think the concept of instantaneous velocity is clear. Okay, now please note one thing, that when you are saying that a body is traveling with uniform speed, as we have discussed in the previous class, it is not necessary that the body will also have uniform velocity. A body moving with uniform speed can have uniform velocity or also not, because when you are saying that a body is traveling at uniform speed, direction may change. So the velocity can be non-uniform, even though the speed is uniform. But when you are saying that a body is moving at uniform velocity, then definitely 100% the body is also moving at uniform speed, because for a body to move in uniform velocity, it needs to have uniform speed as well as the same direction, constant direction. So uniform velocity, okay, then you can say that yes, body is also having uniform speed. Okay, so these are small things that you need to remember. Okay, I think it will be better for you to just keep on noting so that you don't forget these things. Okay, fine. Now, the next thing that we are going to discuss is acceleration. Okay, so acceleration. So what is acceleration? It's quite easy. When you are saying, say, you might have often heard the term that while starting a vehicle, a bike, a scooter or a car, okay, you have heard that term that press the accelerator, okay, press the accelerator or hit the accelerator hard, okay. So what is that accelerator? Okay, it is something that which you press and suddenly you see that the speed of the vehicle or the speed of the, it can be anything, changes. Initially the car or bike say was standing, the velocity was rather 0. Now you press the accelerator, it starts moving, so it's now having a velocity other than 0. So definitely the velocity has changed. Okay, it may be a small value or a big value, that doesn't matter, but it has changed. So this change has occurred in certain time, okay, in certain time. So this is actually called acceleration. Okay, so I can say that the acceleration is the rate of change of velocity. Okay, in previous class, in your previous class, okay, you might have read that the acceleration is the rate of change of speed, but by definition wise, actually it is said that the acceleration is nothing but the rate of change of velocity. Okay, so it actually represents the rate of change of velocity, not the rate of change of speed. Okay, so actual definition is rate of change of velocity. So when a body moves, okay, and its velocity suddenly changes, it is said to have acceleration. Now generally acceleration means increase in velocity. Generally acceleration means increase. Okay, that is also another concept where the velocity might decrease. So that is called retardation. So when this acceleration is negative, okay, when acceleration is negative, then it is called retardation. What happens in acceleration? Your velocity increases. It's the change is having a positive value, and when the velocity decreases, okay, it is said to be retarding or retardation. So it's the same thing. Both are rate of change of velocity, but in acceleration rate of change of velocity is positive, is increasing, whereas in case of retardation it is decreasing. Okay, fine. So these are the concepts that you need to remember. Now here also you will have uniform acceleration, non-uniform acceleration, as well as instantaneous acceleration. So what is uniform acceleration? So okay, but before that just let me write down the mathematical formula. So for acceleration is change in velocity, acceleration or retardation also, same formula, change in velocity by time taken for this change to happen, okay, this is called retardation or acceleration both. So this is the mathematical formula. Now you have uniform acceleration. What is uniform acceleration? When a body, what happens, its velocity is changing and you observe that the velocity is changing uniformly, that is the velocity is increasing or decreasing at an equal value in equal time intervals, then it is said to be uniform acceleration. So for the first second the velocity increases by 2 meter per second, then for the next second from 1 second to 2 seconds again the velocity increases by 2 meter per second, then from the third second, that is 2 seconds to 3 seconds, again the velocity increases by 2 meter per second, then this is to a uniform acceleration. On the other hand, if the velocity does not change if I equal value in equal time intervals, then definitely that velocity, that acceleration is called non-uniform acceleration. Okay, so for non-uniform, the value by which the velocity changes is not equal in equal time intervals, that is non-uniform acceleration. And for non-uniform acceleration, you will have instantaneous value, that is called instantaneous acceleration for that particular moment of time, very small moment of time. So acceleration, as you know, is also vector quantity because it is the changing velocity. Velocity is a vector quantity, so acceleration is also a vector quantity. So it can have both positive and negative values. Okay, so I think with this, the concept of distance, displacement, speed, velocity and acceleration is clear. Rest and motion, these two terms must also be clear to you by now. So with this, we end our lecture here today. If you have any query, any problem, please do mention in the comment box. We'll be happy to solve your problem. Please do study well. Till the next video, we will be coming back soon. Okay, so thank you. Goodbye.